Hey, so next up we're going to talk about buttons, push buttons. And I've got one here. You can see it's just a little button that you can press like that. And you might see them looking a little bit different to this. So this one has a little cap on it. Usually if you buy them from an electronic shop, they look like this without the little cap. But the little cap is just to make it look nice. Look at more like a button. So buttons can be tricky, they can be a little bit confusing because they have 4 pins on them. You see those 4? Now, they have 4, but in reality, they only have two, two sides to the button. One side that will let the current in, one side, and then the other that it'll pass through and go out once you press the button and make the connection. So if you look at it so that the pins are on the top and the bottom like that, the important thing to know is that these two are connected to each other and these two are connected to each other. So I'll show you in practice. This gets a little bit confusing, so bear with me. I've made a little circuit here with a button connected up to the battery like we did with the breadboard, and you can see if I press the button that the LED will turn on. So what's going on here is we have our battery pack here with its positive and negative connection. I've connected those up to those positive and negative rails. You'll remember that these go all the way along, but just these two, the rest of them just go vertically like this. So I've got power coming in this side along this rail, and then it's connected to this wire, this red wire, into, you can see, one side of the button. So it's lined up with the pins on one half of the button. Then when I press the button, it goes through the button, comes out these other pins, goes over into the positive side of the LED, then through the LED and out to the negative side of the battery. So that's the circuit that we have going in here. It's like coming in into one side of the button. When we press it, through the button, out the other side, into an LED, and then out the other side. When I say that the 2 pins are connected, this can get a little bit confusing because we remember that there's a gap in the middle of the breadboard. These columns aren't connected to these columns. But when I put a push button across the middle like this, and I put it across the middle because these are just too big and they don't let us have any space on the board. If I put it down here, you can't put any extra holes in. So because this pin and this pin are connected, this whole line is all connected together now. This whole column that goes all the way from here to here. And the same with this one, all the way from here to here. So the trick with this is we can connect the positive side coming off of the battery through the rail to the top right pin or the bottom right pin, and it'll still work. We can also move this one that's going from the button to the LED, from the top right to the bottom right, and it'll still work. The important thing is to remember that one half of the switch is the pins on the left and the other half is the pins on the right if you put them in vertically on the columns like that. So I'm going to take it over to Tinkercad now and we'll put together that circuit again ourselves and you can see how it works. Now if we go over here to Tinkercad, we can make exactly the same circuit through this. So again, you just click on circuits over here, then create a new circuit. Just wait for a few seconds while it loads up the simulation environment. And we're going to use the breadboard again. So we just click and drag it over. We're going to use the 5-volt battery. We're going to use an LED. And up here in search, I'm going to type in push button because that's the type of button we're using. And you can see it pops up here. So we drag that over. So the first thing I'm going to do is connect up the battery to our power rails again so that we have all those available to us. So just click on the positive, go to the positive rail, click on negative, and go to the negative rail. I'm going to change the colors again. You don't have to, it'll work just fine. It just to show you which one is which. Back. So the next thing we're going to do is take our button and put it here. So like I said, these buttons have 4 pins, 1, 2, 3, 4, but these 2 are connected together inside the button, and these 2 are connected together inside the button. So you really only have 2 pins. But by putting it across the middle of the breadboard like this, usually these columns are, they stop here at this middle line, but because we have these 2 pins connected, it's making a bridge between the two. So now all of this row, or all of this column, are all connected together, and all of this column are all connected together. So we're going to take our LED and just pop it down here. Now, there is something I'm going to do here which is a bit funny, because you remember that this one was the positive and this one is the negative. And since we're going to have positive coming through the battery and over here, it's a little bit easier if we just click on it and go up to this rotate, and we're going to rotate it round. So now that we know the anode, the positive side, is on the left and the cathode is on the right. So we're going to take our positive rail here, and we're going to click anywhere here and bring it down to this column with the button. Then we're going to imagine that the power is going to come out here, come down through here across the button, and then it's going to come out this side over to one half of the LED, and then from the other half of the LED back up to ground. So we're going to imagine it comes out the battery, all the way down here, down through this, in here, through the button when we press it, out the other side, into the LED, out the LED, and back up to ground. Now, if we hit start simulation, what we should see is if we press this button, it lights up. Great. Okay, so that's a pretty interesting start. We've got a button that's working now. That's pretty great. We can do some more interesting things. So if you remember back in the first video, we talked about circuits in series and circuits in parallel. We can also wire up things like buttons to be in series or parallel. So I'm just going to delete these wires so we can start again. There we go. And I'm going to click on this button, and I'm going to hit, I have a Mac, so it's Command C and Command V to copy paste out another button. So now we have 2. You can also, if you want, just drag one over from the left as well, or from the right. So if we wanted to make a circuit where we had to press both buttons simultaneously, what we'd have to do is go from the positive down to one side of the button. So positive to one side. And then we imagine it going from here down through this button, out the other side, over to this other one, in this side, and then through that button, out this side, over to one half of the LED, and then back to ground again. Right? So from power, through the button, through it, at the other side, in this side, at the other side, through the button and back, or through the LED and back. So what happens in this, if we hit start simulation, if we click on this button, nothing happens because this part of the circuit is still open. If we click on this one, nothing happens because this part of it is still open. What I'm going to do is I'm going to hold shift while I click on both. So I'm going to click on this one and click on this one, and you now see that it's lit up because the power has to go through both. Both of them have to be closed. In real life, I would be putting one finger on this button and one finger on this button to press both of them at the same time. Now, the other thing that we can do is to make it so that you can press either button rather than both. So to do that, if you remember about putting things in parallel, we could do this with these buttons by, say, putting this one up here. Copy room, I think. If we had like an infinite amount of space to do this, then we could like put it all in one row on top of each other. Actually, I'll just leave them where they are. So what we have to do is give the electricity two routes so that it can go through either button to light up the LED. So to do that, we want to connect this rail to this rail. So now all of this is all the same. It's all connected. So like these ones, these are through these two pins, then to this one, this connect over and back up here. So they're all the same. And we'll also take going from the right hand of the button to the right hand of the other button. So now all of this column and this column are all the same. So from there, we can wire it up just a little bit like we did before. So we go some positive into one side of it. Positive into one side, it would go through the button, but also it would connect through here and it would go through this button. So we can go from here to here and from here back to ground. Now I know this looks a little bit confusing. I would highly recommend that you play around with this and try it yourself. But what we have here is the right hand side of this button and the right hand side of this button are both connected together, and the left hand side is connected to the left hand side. So if we hit start simulation and we just click on this one, it lights up. And if we click on this one, it also lights up. The electricity has two routes to go through, so either of these buttons will work. So you can imagine how some of these would work for a puzzle, maybe something like that pressure pad that we had in the very first place. And if we made it so that these buttons, if we get rid of this and then bring this back over here, what we have is again and move this here. So this is the first one, this is two buttons in series. So electricity going through, one into the other and then back out. So in this one, we would have to press both. I'm holding shift again to press both. And it didn't let up. Oh, it's because I didn't hit start simulation. Okay, start simulation. If we press both while holding shift, you see this little light. So you could make something like two pressure pads and have people standing on opposite sides of the room, and that they have to stand in a certain place to trigger the output of a puzzle. You can do this with as many buttons as you want. So if we just move this over here and get rid of these wires and drag over another button, then we could do exactly the same thing by kind of daisy chaining them all together. I'm bringing this one to the positive of the LED and this back to the negative. Now if I hit start simulation, if I press one, it doesn't work. If I hold shift and press two of them, it still doesn't work. But when I hit the third, when I press all three buttons simultaneously, then it will light. But it's exactly the same thing. You're just running them in series, like we had with those two LEDs in the first one. Okay, give it a go. So there's one other thing to let you know about, which is a really common mistake that I found my students made, which was that if we look back down at this, and what I have here is I have the LED, I'm just going to take this out so you can see it. I have the LED so that one leg of the LED is on one pin of the button and the other leg is on the other. Now this is going to do something a bit funny. If we run from the positive to one side, to the positive side of the LED and to one side of the button, and the negative to the negative side of the LED and the negative side of the button, what we've got there is that it will light, and really confusingly it will turn off when I push the button like that. So what's happening here is that the button isn't doing anything when the LED is turned on, because just positive coming on one side of the LED across and then out. But how the button is working, if I take another wire and use it instead of the button, if I connect between one side of this LED, this one's a little broken, and to the other side of the LED, it'll turn off. And the reason for that is that electricity is super lazy. You've heard of taking the path of least resistance. That's literally what it will do. So this LED has a certain resistance that is higher than this wire. So given the option of going through the LED or through the wire, which is what's happening here if we put this across, it turns off because the electricity doesn't want to go through this and do any work. So what you're making is a short circuit. So it's coming in one side of the battery straight through this wire and then out the other side. And exactly the same thing happens with a button because they work as a wire bridging the two halves of it. So when I turn it off, the whole thing short circuits, and that's why there's no power to the battery. That's why you have to put them in series like this. So one side of the button, out the other side into the LED, and then the LED back to ground, and then that works for turning it on.